So now let me just show the image to you. Okay, so you can see this is actually a lot better than the previous image, right? You can actually see the tires are so clear, right? So let's get started, guys. So first of all, before we write any code, it will be so helpful for you if I just explain you what are we actually going to use to generate the images, right? So we are going to use diffusion models, and I'm not going to go deeper into the mathematical implementation of it because that is like totally different topic, and that will take like many hours to explain you. So I'll just explain you from the top what diffusion models do and how they help us to generate images, right? So other than diffusion models, we also have GANs, generative adversarial networks, right? You can use those also to generate images or audios or videos, anything, right? And you can also use diffusion models. They perform better than GANs to generate images, right? So what they do is while training, because in training, so like whenever a model is built, first of all training is done, then testing and validation is done, and then it is put to production, right? So during training, what it does is, let's say we have given it some images, let's say this image of a cat, right? So what it will do is it will try to reach to the stage of noise. This image is called noisy image. It is totally unpredictable that is this a cat, is this a dog, or what exactly is this, right? So how it gets trained is, first it starts with the image of a pure cat, like clear image of a cat. Then it adds certain noise. You can see this image, it has some particles of noise, right? And after that it tries to go back, like it tries to predict the image back, right? Then if it does successfully, then it will add more noise. Then it will again go back, that whether it is able to generate or whether it is able to reach to the first clear image or not, right? So that's how it is done, and then it reaches to the final noisy image, and then again it tries to generate the real image, or it tries to reach to the real image from the end, right? So that's how it trains itself, that hey, if I start from the clear image and if I reach to the noisy image, am I able to reach back to the clear image or not, right? And if it has learned this process, that means if we give it a noisy image, right? If we give it a noisy image of this, like whatever insect is this, if we give it a noisy image and tell it to generate the real image, now it has no idea about these steps, right? It has to automatically reach to this clear image step by step. So that's how the generation process works. It will start from a noisy image and it will reach to the clearer image or the final real image. So that's how it generates a clear image, because during the training it got trained on this process of generating a clear image from a noisy image step by step, right? So that's how this whole diffusion model system works. I hope it is clear. If you did not understand, put me in the comment section. I'll create a separate dedicated video on this diffusion models only. Okay, so this is all good. Now to use a diffusion model, we have to go on Hugging Face and actually see which model are we trying to actually use, right? So let's go to Hugging Face. So I've already told you what exactly is Hugging Face. So it's like GitHub. On GitHub you see code repositories. On Hugging Face also there are repositories, but these repositories contain the code of machine learning models, or they contain data sets, right? So basically it's like a machine learning community, just like GitHub, right? But everything is related to machine learning and artificial intelligence. Okay, so this is what Hugging Face is. And over here, what I have to do is I have to search for a model. So I'll just go on the models tab, and I'm going to use dreamlike diffusion. So, and my task is text to image generation. So can I find, yeah, text to image. So this is the task that I have to perform, and I am going to search for the model. So let me search for the model, dreamlike diffusion, dreamlike diffusion. Yes, this is the one, dreamlike diffusion 1.0. This is the model that I have to use. You can see it's an image generation model, and it is free of cost. You don't have to pay anything, and it generates so realistic images. You can see it is so good, right? So that's what we are going to use. We are going to see how to use this model, image generation model, a diffusion image generation model, how to use this in our Python code, like in the code that we are going to generate, and how to actually generate your image, right? So this uses diffusers library. So this is a library which is created by Hugging Face itself, right? So let's go on our Google Colab and let's start writing down the code. So our code is going to contain certain pieces. So first phases will definitely be importing and downloading all the packages and all the libraries. In the second statement, the second piece of code, I'm going to generate one pipeline. So pipeline means that I'm going to define my model that, hey, dreamlike diffusion is the model that I want to use. And after that, I will define the data type and the tensors, everything. So let's do it step by step, right? So first of all, what I'm going to do is I'm going to say, hey, pip install diffusers library, so that I can use diffusers, and I also want transformers, right? So these are the two libraries that I need, diffusers and the transformers. So let's just hit shift enter, and this is going to download diffusers and transformers. So both of these libraries are from Hugging Face itself, okay? And using these two packages, you can actually go ahead and create a pipeline that will use this model at the backend, and on the front end you are going to see the image based on the prompt that you have entered. Okay, so let's wait for it to download, and till it downloads we can actually start importing diffusers. So from, let's go down, from diffusers import stable diffusion pipeline. So this is the class that I have to import, stable diffusion pipeline. So stable diffusion is another company. So stable diffusion is another company. Stability AI, this is the company. Stability AI is the company, and stable diffusion is the class, right? So this company works on this whole diffusion thing, right? And they have created this model. So you can just go ahead and read more about them. They also offer their own API. If you want to pay and use them, you can definitely go ahead. But this model is almost free, right? It is almost free. They have such a good free tier, right? So now let's go ahead, and our requirements are already satisfied. That means we have downloaded transformers and diffusers, right? And I have imported stable diffusion pipeline also from stability.ai, right? Now the next thing I have to import is matplotlib, because I have to actually show the images, so that we can do using matplotlib. And definitely at the end you need PyTorch, so import torch. So once you have done this, you have imported all the classes that you actually need. And maybe my torch is also not there, so let's see if it gives an issue in importing the torch. Then also we have to install the torch, right? So after that, what we have to do is we have to create a pipeline, and yeah, let's do it. So it's done. Okay, so now I'm going to define my machine learning model, right? I'm going to define my machine learning model. So my image model is going to be dreamlike diffusion, dreamlike art. So we can actually see the model name from here, right? So if you see the documentation, yes, this is the model name. So I'm just going to copy this model name, or model ID you can say. So it's not the model name, it's the model ID. So I will just paste it over here. So this is the model ID. I have defined my model ID, and the next thing I have to do is I have to create a pipeline. So pipeline is equal to stable diffusion pipeline. So stable diffusion pipeline brought from pre-trained, then the image model, right? So this is the line that you have to write down. So what it says is it creates a pipeline, right, using the stable diffusion pipeline class, and in that I'm going to use from pre-trained model. So because this model is pre-trained model. Why pre-trained? Because I'm not going to train this model. This model is already trained. Yes, I can fine-tune it, right? I can fine-tune this model and I can train this model on my own data. Yes, I can do that. But basically this model is pre-trained, right? You are understanding that, right? This is a pre-trained model. That means it is already trained by the stability diffusion, stability.ai, right? And I am here just to use it. So that's why from this class I'm going to import a pre-trained model. Which model? This image model. And these are certain parameters that you have to already define. So torch data type is torch.float16, right? And after that I'm going to say pipeline. We have to use CUDA accelerator. So you can see over here also that you have to use CUDA. So I'll just say CUDA. So if you want to write this code in your machine, then you should have this CUDA in your system. But if you don't have CUDA, or if you don't have NVIDIA graphics card and all, then you can directly go ahead and write your model, start practicing on Google Colab. They provide you with all of this architecture, right? So let's write it down, pipeline. This is the name of my variable, right? So here I have created the pipeline. So I'll just hit Shift Enter. So this has given me an issue that, hey, found no NVIDIA driver on your system. So what we have to do is we have to select this and change runtime type and say Python 3 is okay, hardware accelerator is T4 GPU, yes. You have to select that and click on save, right? So this will start connecting again. So let's wait for it to connect. Okay, it is connected. Now I'm going to just say runtime run all. Again, you have to do it. So let's just wait for a minute. Okay, congratulations. Now it has installed everything. So our pipeline is also now ready. Now this is the time we start generating the images. So let me write down the code. And yes, because it is text to image, so I have to write down my prompt. So I'll define my prompt, and my prompt is going to look something like this. I'm going to say a dream-like character, a dream-like studious character, studious boy character who is currently sitting on his study desk and is sweating a lot because of I'm just writing anything, right? I'm just writing anything because of the temperature. Let's see what we get, right? This is just a free trial, like we can do anything, right? So let's see what we get. And we also have to, so this is my prompt, and as soon as I've written my prompt, I'm going to define my image that is to be generated. So I'll store it in a variable called image is equal to pipeline. So it is suggesting me pipeline prompt, this is my prompt, dot images at 0 and image dot save. So I'm not going to save it. I'm just going to say I just want to show it, right? So yes, it is suggesting me the right thing, that is plt dot I am show image, right? So this is what I have to do, and you have to also switch off your access. So plt dot access off, plt dot show. Yes, this is, I think, good enough. So I'm just running it. So it might take some time because it has to like go to, yeah, it is generating. So let's just wait. So guys, this is the image that is generated, and it is actually very good. So I cannot see the sweating, but I can actually see this red area here. So maybe this is because of the temperature, and you can see the hands are not that perfect. You know, both of the hands are actually the same single object. So maybe, so we know that hands are something very complex for these image generation models to generate, but actually this is a very good image, like, right? So I just want to try one more time. So I want to say create a Disney-like character, a Disney princess character who is riding, or who just fell from a unicorn. I want to see what it generates. So it has not given me the princess, but it has given me the unicorn. Okay, that is good. So I'll just try one more time, some complex prompt. Online cab. Yeah, let's just see what we get. I'm just excited to see this response. So here I get the astronaut image, and yes, it has landed on some island or on some planet. I cannot see him booking a cab, but okay, that is fine. So, but we are, like, it is actually good. The results are actually really impressing. My prompts are actually confusing, but the results that we're getting are actually really amazing, right? Now what we have to do is we have to start exploring the parameters which are there in this this class, stable diffusion pipeline. So what I'll do is I will create a heading over here, and I'll say params in stable diffusion pipeline. Okay, and I'll just make it bold. Okay, so which all parameters we get? So first parameter that we get is over here itself. I'll write it down. So the first parameter that we get is number of inference steps. The amount of steps you increase, the more better results you're going to expect, right? So number of inference steps. So this is the first parameter. Next parameter that you get is negative prompting. So negative prompting. Third parameter that you get is height and height. Fourth that you get is width. So that basically that actually means that you can also adjust the dimensions of the image. And last that you get is number of images per prompt. So number of images per prompt. So there is no of actually, number images per prompt, right? So these are the parameters that you can actually provide to your pipeline, and based on these parameters your results will be generated. So what I'm going to do is I'm going to define one more prompt here, or I'll just I'll say prompt 1 is equal to, so the prompt which I'm going to define is a Shiba dog riding a bicycle. Right, so this is my prompt. Okay, and let's just define the pipeline also. Now the next step is I'll say images is equal to, and I'll just call pipeline prompt 1 number of inferences 100 dot images, right? So this I have to show, right? So I'll use matplotlib. So let it generate, right? So this is done. Now I'll say images at 0. Not images, I have to actually put this inside the matplotlib show function. So I'll just bring this one from here. Okay, here it is. The image is here, and it is actually really realistic, right? So some problem is there with the tires and all, but there is a Shiba dog riding a bicycle, which is actually really cute. Okay, now what I'm going to do is I'm just going to increase the number of inference steps, and now let's just generate. So now let me just show the image to you. Okay, so you can see this is actually a lot better than the previous image, right? You can actually see the tires are so clear, right? So this is really the better image, right? Now let's see the other parameters. So I'll just increase the font size again, right? And now what I'm going to do is I'll just say Control C and Control V, and I'll make the inference steps as 100 and just say height is equal to, let's say 200, and width is equal to 100, right? And now let's just see images at 0. Let's see what we get. Okay, so what is the problem? To be divisible by 8, but okay, sorry. So I'll say this one as 512 and this one as, let's say, 1024. Guys, this is much better than the previous image also. So here we have two Shibas, and you can see the height and width is also adjusted, right? So this is really amazing, guys. I'm just getting impressed more and more. So this was good, guys. I hope you enjoyed this video. This was really an interesting video to watch and to practice also. So now your next step is you have to just clone everything. So practice on your own. Don't just copy paste, right? And what you have to do is you have to try out these prompts, number of images per prompt and number of inference steps. So these are the things that you have to, not this one, sorry, negative prompting and number of images per prompt. So these are the two things which is, you can consider it as your homework. So you have to try on your own and just post whenever you make the same project, take a screenshot and put it on LinkedIn and tag me. I'll definitely give you the feedback that whether you are doing the right thing or not. So this will also help me understand that hey, you guys code when I teach, right? So, and that is definitely going to increase your LinkedIn engagement also. So I hope you enjoyed this video. Till the next video, keep coding, keep innovating, and thanks a lot.